The star Betelgeuse, a red, unimaginably colossal beast found in the glorious constellation of Orion, has long enthralled stargazers and cosmologists alike due to its sheer size and brilliance. If Betelgeuse were placed where our Sun is, it would expand to the orbit of Jupiter, underscoring its gigantic size. Despite being situated around 642 light-years from Earth, its tremendous size makes it one of the most striking stars visible to the naked eye. Interestingly, Betelgeuse has shown odd behavior, such as surprising dimming and brightening cycles, which many experts believe signal that the star is nearing the end of its life. The renowned physicist Brian Cox recently made a bold statement that Betelgeuse is on the verge of a staggering explosion, expected to occur within the next 14 days. This event, known as a supernova explosion, will mark the end of Betelgeuse's life. However, it will also offer an unprecedented opportunity for scientists to study one of the most enigmatic and powerful phenomena in the universe. As a red supergiant, Betelgeuse is one of the largest and most massive types of stars. It has been on astronomers' radars for a very long time, but its recent unpredictable fluctuations in brightness have sparked theories that it is preparing for a massive explosion. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, triggering a colossal explosion that releases a massive amount of energy, radiation, and material into space. Betelgeuse's imminent explosion is expected to be a Type II supernova. This specific kind of stellar event occurs when the core of a massive star collapses. This collapse triggers the release of neutrinos and radiation, creating a shockwave that obliterates the star. The explosion will be so bright that it could be visible from Earth without telescopes, potentially even outshining the moon in the night sky for weeks or months. While such an event would typically be devastating if it happened close to Earth, Betelgeuse's distance of around 642 light-years ensures that, although the explosion will be visible and dramatic, it poses no threat to life on our planet. Nevertheless, the event promises to reshape our understanding of supernovae and other cosmic phenomena. A supernova explosion is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will in its entire lifetime. Betelgeuse's explosion will not only be a spectacular cosmic display but also a pivotal moment for science. Researchers are eager to witness this event from its earliest moments, using a variety of ground-based and space telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much data as possible. When Betelgeuse explodes, it will release a wide range of radiation, from visible light to gamma rays. One key aspect of the explosion will be the surge of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion due to their ability to pass through almost anything without being affected. Observatories like Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in tracking Betelgeuse's final moments. The explosion will also offer valuable insights into the creation of heavy elements. When stars explode, they produce and distribute elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will give scientists a clearer view of this element formation process, which is critical for understanding the development of planets and the chemistry of the universe. While Betelgeuse's massive explosion is unlikely to adversely affect Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could lead to more intense auroras, extending the regions where the northern and southern lights are visible. While these powerful rays could impact satellite communications and some technologies on Earth, the disruptions are expected to be minor and short-lived. One of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For a few months or even longer, Betelgeuse is expected to be the brightest object in the night sky, potentially even visible during the daytime. This event will not only excite professional scientists but also amateur astronomers and the general public, sparking renewed interest in space science and the cosmos. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the Orion constellation will provoke philosophical reflection on the transient nature of the universe. In some cultures, such cosmic events have been interpreted as signs of great change. Betelgeuse's explosion could inspire a mix of awe, fear, and wonder as people from all walks of life witness the death of a star. This grand event is likely to reignite interest in space exploration and astronomy, drawing more people into the pursuit of knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows almost anyone with a camera or telescope to observe and record the cosmic explosion. This democratization of science will unite people across the globe, all watching and documenting the same monumental phenomenon from their unique vantage points. Betelgeuse's explosion is not just a spectacular event, but also a stepping stone for future research. The data gathered from the supernova will inform how we study other stars, especially as we venture further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is essential as humanity looks to expand its presence in the solar system and beyond. Furthermore, the explosion will reignite interest in the search for extraterrestrial life. Supernovae are responsible for spreading the building blocks of life, such as carbon and oxygen, across the universe. By studying Betelgeuse's explosion, researchers can better understand how these building blocks might spread to other planetary systems, potentially sparking life elsewhere in the universe. The upcoming explosion of Betelgeuse is set to be one of the most significant cosmic events in recent memory. Its supernova will provide an abundance of scientific data, enhance our understanding of the universe, and undoubtedly captivate people worldwide. Betelgeuse's death will mark the end of a giant star, but it will also symbolize the ongoing cycle of creation and destruction that governs the universe. It reminds us that from death, new stars, planets, and even life itself can emerge. As Betelgeuse approaches the final phase of its life, one of the more speculative yet intriguing possibilities associated with its impending explosion is the potential to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These elusive forces are believed to account for most of the universe's mass and energy, yet they remain poorly understood. Some researchers hypothesize that supernovae like the one anticipated from Betelgeuse could hold the key to unlocking these secrets. Supernovae release vast amounts of energy and radiation, and some scientists believe these immense forces could interact with dark matter in observable ways. One fascinating theory is that dark matter exists as weakly interacting massive particles, or WIMPs. If WIMPs exist, the energy from Betelgeuse's explosion might interact with them, creating detectable signals or patterns. Moreover, the shock wave from Betelgeuse's supernova will interact with the interstellar medium, the gas and dust between stars. Observing how this shock wave propagates could provide indirect evidence about the distribution and behavior of dark matter in our region of the galaxy. Similarly, the energy released could offer clues about dark energy, the mysterious force driving the universe's accelerated expansion. Betelgeuse's explosion will also be a prime opportunity to refine distance measuring techniques in astronomy. Because it is relatively close to Earth, the light and radiation from the supernova will allow astronomers to calibrate cosmic distance ladders with greater accuracy. This, in turn, will help improve our understanding of the scale of the universe and the rate at which it is expanding. For scientists studying the life cycles of stars, Betelgeuse's explosion will offer invaluable data on how massive stars end their lives and contribute to the cosmic ecosystem. Supernovae are essential for spreading the heavy elements necessary for the formation of new stars, planets, and even life itself. By closely analyzing the explosion, researchers will gain deeper insights into the processes that drive stellar evolution and element formation. From a cultural perspective, the event will likely leave a profound mark on humanity's collective consciousness. The sudden disappearance of one of the night sky's most recognizable stars, followed by its dazzling explosion, will remind us of the impermanence of even the most seemingly eternal aspects of the cosmos. It will also serve as a stark reminder of the dynamic, ever-changing nature of the universe. For future generations, Betelgeuse's supernova will stand as a landmark event in astronomy. The knowledge gained from this stellar death will shape the way we study stars and galaxies for decades to come. It will also underscore the importance of continued investment in space science and exploration, inspiring new generations of scientists, engineers, and dreamers to push the boundaries of what we know about the cosmos. The aftermath of Betelgeuse's explosion will be as fascinating as the event itself. As the supernova fades, it will leave behind either a neutron star or a black hole, depending on the mass of its core. If Betelgeuse forms a neutron star, astronomers will have the opportunity to study one of the densest objects in the universe, where matter is so tightly packed that a single teaspoon could weigh billions of tons. Alternatively, if the core is massive enough, it may collapse further into a black hole, a region of spacetime where gravity is so intense that nothing, not even light, can escape. Observing the formation of a black hole in real time would provide unprecedented insights into these mysterious objects, which are thought to play a critical role in shaping galaxies and the universe's structure. The shock wave from the supernova will ripple through the interstellar medium, compressing gas and dust in its path. This compression could trigger the formation of new stars and planetary systems, continuing the cycle of stellar life and death. Betelgeuse's explosion may, therefore, sow the seeds for future generations of stars, illustrating the interconnectedness of the cosmos. For Earth-based observers, the visual spectacle of Betelgeuse's explosion will be unparalleled. The supernova's brilliance could inspire a wave of public interest in astronomy, similar to how Halley's Comet or other celestial events have captivated humanity in the past. Schools, observatories, and science institutions worldwide are likely to use the event as an educational moment, encouraging curiosity and learning about the universe. Beyond its scientific and cultural significance, Betelgeuse's supernova will serve as a reminder of our cosmic fragility. While the explosion poses no threat to Earth, it highlights the immense power of the universe and the forces that govern it. Events like this underline the importance of understanding celestial phenomena, as they can occasionally have more direct consequences for our planet. As humanity witnesses the final moments of Betelgeuse, we will also be reminded of the vast scales of time and space that define the cosmos. Stars like Betelgeuse live for millions of years, far longer than the span of human civilizations. Yet, even they are not eternal. The death of Betelgeuse will serve as a poignant symbol of the fleeting nature of existence, both in the heavens and here on Earth.